Hey guys, let's solve the problem 2709, greatest common divisor terror. Okay, so let me explain the explain the question behind this problem. What the question says? I have an index. I have an array of some indexes. Okay, A, B, C, D, and E. Okay, now the thing is, I have if I'm standing at any position. Then I have to say that can I move to any place? Suppose I am at B position. So can I go to A, B, C, D? Okay. Now same thing here is if I'm standing at A, then can I go to B, C, D, E? If I can go from A to B, then I can go from B to any places. So I have to tell true if I can go from any index to any other index. Suppose I am standing at I index. Then can I go to J index if this is true or hold the arrays, all combination of I and J, then I have to return true, else I have to return false. Okay, so this is the main intuition. So what can I do is, and the thing is, the path is only, the thing is, I can make a path by GDC. GCD, sorry, GCD, I mispronounced it. GCD. If the GCD of A and B is greater than 1, the greatest common divisor, okay, it is 1, then I can make a path. Okay, so if B and C's path is GCD is greater than 1, then it is correct. Okay. So, first thing that I can think of is, um, suppose I have 4 indexes, okay, then I can make an n square loop and find the GDC of I and J. And if the GDC is greater than 1, then I'm putting a graph where the index is like this. Okay, that means we can go from J to I, and I can also go from I to J. Okay, and for the more intuition, that is, I can use a disjoint set DSU, in which I can see that from I can go to J to A to C to B, like this. And this intuition is good, but the thing is, when I solve with this intuition, I got the TLE. Okay, because for DSU I'm using an N square, which was not feasible. Okay, so I cannot use the GCD. Thing was, if I using GCD, then I can go for A to D, then E, then like this I can make a valid path. And if each element have the parent I, then I can say that it is a valid path and I can return a true. Okay, and if I have something like F which has the parent G, okay, the two parents are not same, then I can have to return false. Okay, this is the DSU concept, but the thing is, it was taking n square loop. So how can I optimize this? Okay, so what can I think of is, I have to find GCD. Okay, and GCD contains prime numbers. Okay, if I can say that, suppose if I have 10, I can find the prime number of this, prime factorization, 2, 5, okay, or 2, or we can say 2, 2, 2, 2, 2, okay. So I can find bonus factors, okay. Like suppose I have 8, I can say that it is a 2, 2 is a factor, 2 into 2 into 2, okay, 4, 4, okay, sorry. Yeah, this is the prime factor, and I can say that with the prime factor of 2, I can go to 8, I can go to 10. Okay, suppose this is an array, and if in that I have 10 and 8, so I can say that with a 2 as a prime factor, I can go from 8 to 10. Okay, suppose I have 9, then I have to contact drive. Yeah. If I have a 9, I can say that I can go for 3 to 10, and I can have a 12. which is like this. Suppose this is a format here in which 8 is a prime factor. With 8 to 10 and 12, I have a common prime factor 2, and with 12 and 3, I have a common factor of 3. Okay. Now, if I'm standing at 8, I can go to 9. How? I can go from 8 to 12, then I can go to 12 to 9. So this is the main concept behind this. What I do is if I have an array like this, 8, 10, 12, 9. So what I can do is I can uh, find the prime factor of this, which is 2. 2. Okay. Smallest prime factor. I have 2 and 3. Okay. And I have 3. Okay. So with this, and I can form the graph between the same values. Suppose I have 2, 2, and 2. I can make a graph in this manner. And I have 9 and 12. I can make a graph in this manner. Okay. So here's the main concept. So what I have to do is, let me write down the steps. First, I have to find the prime factor of all the numbers. Then I have to join the prime factors in a form like this. Let me try this. Um, this form, okay, where the 2 is the node and the children are like this. Then what I have to do is make the graph. And the graph would look like this. 8, 10, 12, and I have this, and with 9 I have like this. So see, I have made the graph, and let me start. And so okay, so first I will find the prime factor of all these numbers. Then with the prime factor, I'm going to make the graph in a way like this. Then I'm making the graph between each one. Okay, so this is the graph. And if the graph is connected, means true. I can go from any node to any node. Suppose I have 10, suppose I have 7, which is not a correction. So I will return false. Okay, this is the main concept behind this. Okay, the 3-step solution. First, let's prime factor, join, and graph. Okay, now how can I optimally find the prime factors? If you have heard of sieve, then you can find the smallest prime factor. Smallest prime factor. Okay, I'll teach you. I'll let you code about this. Okay, the sieve method. Then what I can do is I can find the smallest number, smallest prime factor of these numbers. Okay, then I will form the prime factor of each elements like this. Okay, let's go this. Okay, let's find the Steve. Let's find the Steve. Okay, okay. Now, suppose let's find the length. Let's declare all the constant in starting. Okay. Okay. Now, what I have to do is I have to find the prime factors. So the max to max I can go for how much numbers I have to search for. Can I go for 10 to the power 5? Okay, 10 to the power 5. Okay. Now, the max amount of prime factors that I have to find. Now, I need an array which stores is the number prime or not. Is prime. Okay. This will tell me if the index number is prime or not. Okay. 1 means it is a prime number and 0 means it is a not prime. Okay. Now, let's code this tree method. Okay. So mm, I need a array which will store the smallest prime factor. Okay. So what can I do is I can smallest uh, prime factor. Okay, image I or I in range store the smallest prime factor. Okay, so here. Um, First thing is the 0 and 1 is not a prime number. So let's fill this out. Is prime 0 equal to 0 and 1 is also 0. So I write the base condition of this table. And if you want to learn more about this table, you can just go and learn this. And okay, so in this, what we have to do is I will go for 2, and for all the two values, multiplication of 2, I am just marking them non-prime numbers. Okay. And for 3, same 3 to 9 and 12 and 15 and 16, like that. 3 to 6, 6 is I'm not going to make it green because 2 has already done this. Okay. So this is the main question, and let's code this. Okay. Now, for I in range, for how much values do I have to find the max value? Right. Okay. I found max. And since I have already found the prime number of these two, so start on the max. Okay. And what I have to do is I have to run this for if the I value exceeds the max number, then I have to break this. Okay. If is prime I equal to 0, then continue. If I'm in a position in which it is already not a prime number, then I have to skip the positions. Okay, skip that number. Okay, now the main condition. So with j in range I into prime and max value, and I'm pressing I, or I can say into 2 or plus means I will run 2, then 4, then 6, then 8, then 10, like this. Okay, the j will move like this till I then reach the max value. Okay. Now, if prime j, if I have a prime, if I have the j value which is in a condition I have never reached that position, I will just simply do this. Make the smallest prime factor of j equals to I, and what I do is prime equals to j. Okay, so I have done this thing. For 2, I'm marking the SPF of all these values like this. Okay, so and at the last I'm doing the 0. So I found now I have to find the prime factor of all the numbers. So let me try out Now let me write the function find prime factors. Okay, for this I'm sending a number, and in this I'll need all the possible values that I can need in a find the prime factor. So what I can do is and let's make a set, and while and I'm going to just put the smallest factor of that n value, and I'm going to divide that like this. Okay. Now I will return this. Thing is, in this I'm finding all the prime factor of the value. Okay. Suppose I have 12, then it will take 2 and 5. So like this. Suppose I have 12, it will divide 2 and will give 6. Then 6 will divide, 6 has the prime factor of least number is 3. It will return 2 and it will return 1. So it will not return 5, it will return 3. So this will give a value of 2 and 3. Okay, let's just print this value if it is correct. Let's return a 1 for a while and print um, prime factor of 2. Mm, mm. Okay. If n greater than this, let's run this again. I was just making a loop for a infinite time. Yeah, that right. I don't need this. Space dot add and oh, I didn't call this Steve method. Let's find first. I will find the prime. Yes, I have to fill this. Yeah, the 12 will return 2 and 3. Okay, so from this value to this, I have correctly. Let me take this. Yeah, I have correctly do this. Prime factor is done. I have to now make the array in which it will contain all this. Okay. Now the thing is, I have found all the prime factors. I have to find the prime factors. For this, I have code the Steve method and SP. Okay. Now let's do this. What I have to do now is make a graph join. Okay. In which the prime factor will be like this and it will connect it to all the numbers. Okay. So let's join the number index in a way that that the parent are the prime factors. Okay, in which this is not with the 8, it would be the index. Okay, index of 8. Suppose 1, it would be 2, like this. Okay, it will not be 8, it will be the index. Okay, so let's join equals to a graph, and let's make this a simple graph. Okay, simple hash map for I in nums. Let's iterate over the and for j, and I have to find the prime factors of this. Right. Okay, in which I'm iterating over the nums array and iterating over the prime vectors of the I. Okay, now I have to join them. So if I have to find the index, and the thing is, if uh, yeah. Now let's put in the array, put in the joins. If j not n joins, then I have to create like I. For I need the rate, yeah, the I would be the value, and I have to find the n. And if it is already present, then I have to just append I. Okay, so I have successfully make the uh, make a graph of prime factor with the indexes that is present. Okay, so it is done also. Okay, now I have to make the graph now. Okay, we have to make the graph now. And let's make the graph. It's a really big code for it. And like, okay, let's make the graph. For I in range, I will get the prime value. It would be I would be equals to prime number. Okay, now if the length of joins of I equals to 1, then I have to continue. Means suppose uh, I have a number n which only contain a one value, then I cannot connect to its surroundings. I cannot connect. I have to connect with the siblings, and if it already have one, then how can I connect this? Okay, you understand the problem? If I have the siblings, I have to connect the siblings. I am connecting the siblings. Okay, now if only then then continue. Okay, else for here and there I want to length of okay. Then index 1 will be joins of I minus 1 and means I found the index of 8 and index of 10. The index of 8 would be 1 and index of 8 would be 2. Okay, now I have to correct that. Okay, no. Graph. Graph will be like this for I in range n. Okay, and graph and dot and index 2 and index 1. Index 1 and index 2. So I have successfully created the graph also. Okay, I have successfully created the graph. Now the last condition. The last I have to traverse. or I can say check connected. Okay, I have to find the connection. If it is a full, if it is a connected graph, no. What this I can do is visited 0 into n plus DFS node if visited more than continue means a simple traversal of the graph. If I'm suppose I'm starting from the 8, then I will mark the visited 8 as 1. Then I will go for the 10 and 12. I will mark them as 1 again, then going to 8 like this. Now suppose I get all these positions but the 7 is still 0. Then I will say that the false. And if I don't have the 7 and I got all the no visited. Okay, if I don't have a 7, all are visited, I have written true. Okay, this is the question. So list no equals to 1 for given graph. Tab nodes are the children of 8. 8 children of the 8 is 10 and 12. Okay. This tab node. Okay. Check if the graph is connected or okay. Or I inject if I is to 0, then return false, else return. Finally, the code is up. Okay. Next, continue. Oh, sorry. Hmm. This is a simple graph. Traversal. What I get? Oh, I don't need joints. What's the problem behind this? Hmm? Oh, sorry. J. It should be J. And yeah. Mm, mhm, mhm. Sorry. Sorry. First, I have to take the I. Then I have to find the. It should run properly now. False true. It's always running false. Okay. I haven't called the DFS. I honestly do. Yeah, it's running fine. It's fine. So just ants. Why? And the list index out of range. Oh, okay, I need to maximize. I have to increase the value now. It will not support. Because in the description it says equals to 10K5. I need some net value a little more margin like this. Yeah, it's accepted now. Fine. Even if I do one, because let's make it 10. So this is the main code. Let me go through the code. First I'll need a max value, then I find the prime numbers, then I find the prime factors. Okay, then what I did is create a join graph. This is the join graph in which the parent would be the prime factor and the value would be the indexes. Okay, then from that I created the graph, and for the graph I just traverse in DFS, or you can do a BFS also. Then I'll check if all nodes are visited or not. If they are visited, then I will return true, else false. Yeah, this is the main code behind this. Hope you understand. Okay, let this I list this. First prime factor, then create a join, then a graph, then checking connections. Okay, the fourth step code. Okay, hope you understand.